Okay, hey YouTube, Sam here from 42 Maths. Today we're going to be looking at discovering primes. I've got my calculator here and we're going to create some random numbers and we're going to try and break them down into their prime factors. So the first number it gave me was 319. So I'm not sure how many prime numbers you're familiar with, but remember, the definition of a prime number is a number that can't be broken down into factors. So 319, I have a suspicion it might be prime, but let's have a think about it. It's odd, so it's obviously not divisible by 2. It could be divisible by 3. What we need to do is add up the digits. 3 add 1 add 9 comes to 13. 13 isn't divisible by 3, so 319 isn't divisible by 3. We can rule out even numbers because it's odd, so 4 doesn't go into 319. 5 obviously doesn't go in. 6 is even, doesn't go in. 7 might go in, let's have a think about it. 7 goes into 350. 319 is 31 less, but 7 doesn't go into 31, so 7 doesn't go into 319. 8 doesn't go in, it's even. 9, let's think about 9. Does 9 go into 319? Well, am I going to cheat and use the calculator for this? Let's do 9 into 319 on paper. So 9's into 3, don't go. 9's into 31, go 3 times, remainder 4. 9's into 49, doesn't go exactly, it's 5, remainder something. So 9 doesn't go into 319. 10 obviously doesn't go in because it's even. 11 into 319. I'm going to speed up the process and use the calculator. Aha, 11 goes in to 319. 29 times. Now 11's a prime number, as is 29, so we can circle those. So 319 is 11 times 29. Okay, so we haven't discovered a new prime number. 319 is what we call subprime because it has factors. Okay, let's do another random number. So let's delete. So a random integer between 100 and 999. That's given us 984. Well, we definitely know that's not prime because it's even. 2 clearly goes into it. So how many times does 2 go into 984? Let's think about that. It's going to be 4, 9, 2. 2's prime. 492's even, so it's still not prime. We can take another factor of 2 out. 246. 246 not prime. 2 goes into it. 123 times. 2's prime. And now is 123 prime? Well, 2 obviously doesn't go in. 3, well, let's add up the digits. 1 plus 2 plus 3 is 6. 3 goes into 6, so 3 goes into 123. So we can break 123 up, and it goes in 41 times. Now, is 41 prime? Pretty sure it is. Okay, so 2 times 2 times 2 times 3 times 41. Let's just double check that on the calculator. 2 times 2 times 2 times 3 times 41 should equal 984, and it does. Okay, alright, so 2 numbers down, and neither of them have been prime yet. 796 is the next number. Okay, so it's even, so it's obviously divisible by 2. Now 2 goes into 800 400 times. So this is a little less than 800. It's 4 less. So if we subtract 2 from 400, we get how many times 2 goes into 796. 398 is even again, so it's obviously divisible by 2. It's going to be 199. Now is 199 prime? I suspect it is. But I can't be sure. It's obviously not divisible by 2 because it's odd. 9 add 9 is 18, add 1 is 19. It's not divisible by 3 because of that. Right, let's double check on the calculator. So we've tried 2, we tried 3. Can't be divisible by 4 because 4 is even. It's not divisible by 5 obviously because it doesn't end in a 5 or a 0. It's not divisible by 6 because 6 is even. Let's try 7. Not divisible by 7. Let's try 9. Not divisible by 9. Not divisible by 11. Not divisible by 13. And at this point we've gone far enough because we've gone past the point where the numbers that are getting smaller are now smaller than the numbers that are getting bigger. So we've ruled out all the potential factors. So 199 is prime. So let's highlight 199. Let's put a nice colour around it because it's a new prime number that we've discovered. So that's cool. Okay, so let's go back in the calculator, just delete these lines of working and generate a new random number, 614. Obviously not prime because it's even, but let's break it down into its prime factors. I'll just write the result of the last one. So 614 is 2 times 307. Now 307 might be prime. Let's have a think about it. 2 obviously doesn't go in, it's odd. 307 could be divisible by 3, but its digits don't add up to a multiple of 3. They add up to 10, which isn't divisible by 3. 4 obviously didn't go in because 4 is even. 5 obviously doesn't go in. 6 doesn't go in. 7, let's try 7. Doesn't go in. Let's try 9. Doesn't go in. Divided by 11 doesn't go in. 13 doesn't go in. 15 obviously doesn't go in. 17 doesn't go in. And we've gone far enough now, because once we go up to 19, these numbers are now smaller than the numbers that were getting bigger. So 307 is a prime. So we can highlight that one. 307 is prime. So I don't know whether you've got a favourite prime number. I particularly like 89 because it's the year I was born, and it's also a prime, which is cool. And I prefer prime numbers to non-prime numbers. I just think they're cooler. Okay, let's do another random number. Let's just delete a few lines of working on the calculator. And that one. And then we can use the random function again, just press execute. Okay, 3, 4, 4. Okay, so we've yet to stumble upon a prime number straight out of the gate. 2 times 86, 2 times 43, and 43 is prime. So when we're discovering these primes, I'm kind of discovering primes that are larger than 100. I'm kind of fairly familiar with primes that are smaller than 100. Because after doing maths for a while, you get used to doing your times tables, etc., and you get familiar with what numbers are prime. So let's try another one. Oh yes, I'm not. Let's just write out. And 3, 4, 4 equals 2 times 2 times 2 times 43. Right, it's 739. Okay, let's have a go at 739. Now it feels a bit like a prime. Let's see if it is. It's obviously not divisible by 2 because it's odd. Let's think about whether it's divisible by 3. Add up the digits. 7 add 3 is 10, add 9 is 19. 19 is not divisible by 3, so 739 is not divisible by 3. It's obviously not divisible by 4 because 4 is even. 5 is obviously not divisible by 6 because 6 is even, so we can just ignore the even numbers. Let's try dividing it by 7. I know that's not going to be a whole number because 7 goes into 700 but not 39. So let's try divisible by 9. Oh, typed it in wrong. Nope. So not divisible by 9. Divisible by 11. Nope. Divided by 13. Nope. So 739 is quite a large number, so we're going to have to... It's obviously not divisible by 15. So we're going to have to try quite a few numbers. But the largest potential factor of 739 is the square root of 739. And that's a decimal. So it's obviously not a square number. So it's 27 point something. So that's how far we have to go with our attempted divisions. Oh, what am I doing? 23. Nope. 739 divided by, obviously not divisible by 25. Divisible by 27. Nope. So now we've gone as far as the square root. So if we divide it by 29, we'll have gone past the square root, which is 27 point something. So 739 is a prime. So that's our first one that we've got that's been a prime straight off the bat. So let's give it a bit of colour. So 739 is a prime, and it rhymes. Okay, let's do another sheet of primes. Tell you what, we'll do it on a fresh sheet. So let's generate a random number. So this is an exercise that you can do at home, and that's a bit of fun, really. So you can do it with, you can start off with numbers between I don't know, 20 and 100. If you're not too familiar with prime numbers yet. And yeah, so let's try 245. Well, we know that's not a prime number because it's obviously divisible by 5. Let's think if there are any numbers smaller than 5 that go in. 2 add 4 is 6, add 5 is 11. 11 isn't divisible by 3, so 3 doesn't go into this. 2 obviously doesn't go in because it's odd. So 2, 3, 4 doesn't go in because 4 is even and this number's odd. So the smallest factor is 5. So let's have a think. It's 49. Because 5 goes into 250 50 times, and we've got 1 fewer 5. 5 is a prime. 49 is 7 times 7. We know that. So 245 is 5 times 7 times 7. Okay, so 245 wasn't a prime. It's what we call a subprime. Let's generate another number. So 482. Let's have a go at 482. It's obviously even. So 2 divides the number. 241. How many times does 3 go into 241? Well, if we add the digits, 2 add 4, add 1, all comes to 7, but 3 doesn't go into 7, so 3 doesn't go into 241. 4 obviously doesn't go in because it's even. Let's try 5, obviously doesn't go in. 6 obviously doesn't go in because it's even. Try 7, doesn't go in. Try 9, doesn't go in. Try 11, doesn't go in. Try 13, doesn't go in. 15 obviously doesn't go in because it doesn't end in a 5 or a 0. 17 doesn't go in, and we've gone past the square root now. Oops. Because the square root of 241 is 15.5. So 241 is a prime. Okay, so we've discovered another prime number. So we can give it green. Green's my favourite colour. Okay, so what prime numbers have we discovered so far? We discovered 199, 307. Sorry about that, it's off camera. 199, 307, 739, 241. So, you might be wondering how often prime numbers come up. And there's an approximation for how frequent prime numbers are. And it's the logarithm, I think, from what I remember. And the logarithm function looks like that. So prime density. So I think there's an approximation where you take the logarithm of the number, and that gives you how likely you are to find a prime. So as the numbers get bigger, primes get less likely, but you still go on discovering primes because this line never goes flat. It's always got a certain gradient. Anyway, I think that's a good point to stop it. And we've discovered some primes today, and hope you've enjoyed the video.